So, hello everyone. My name is Kunal, and I am your mathematics tutor. And we are doing actually indefinite integral. So today is our sixth lecture of indefinite integral. And हमने अब तक जो कल पढ़ा था, like some special cases of algebraic integration, like linear by linear, linear by root of linear, and some quadratic by quadratic, quadratic into quadratic. So मैंने बताया था how to tackle those kind of cases. So उसकी कुछ फॉर्म रिड्यूस करने के लिए मैंने बताई थी. आई होप यू विल अंडरस्टैंड. अगर समझ में दिक्कत हो रही होगी तो यू कैन गो थ्रू द प्रीवियस लेक्चर वन. सो आज पहले हम उस पर प्रॉब्लम करेंगे एंड देन वी सॉ सम मोर type, like how to deal with those. So let's start our today's lecture with some practice problem which were based on yesterday some special cases. So let us begin our lecture. So we deal with the first problem which based on the first type, which is what's our type one. So our type one is, let me maximize it. Okay. So what's our type one? Our type one will be like linear one function by linear function, and it will be like linear one by root under linear two, or linear one into linear two. So मैंने कल क्या सजेस्ट करा था, where L1 and L2 are first linear function and second linear function. So मैंने कल क्या सजेस्ट करा था कि कभी भी इस टाइप का अगर इंटीग्रेंड मुझे दिखता है, लाइक न्यूमरेटर में भी लीनियर फंक्शन हो, डिनोमिनेटर में भी लीनियर फंक्शन हो, so what we have to do, we have to reduce it to form like the function in numerator, the linear function which is numerator uh, can be written in the form of the linear function in denominator with some constant. So look like k1 L2 plus k2. We can reduce the linear function of numerator to linear function of denominator in such a form. And then what we do, we equate and find k1 and k2, right? So let look at some example here. So example based on this type. Okay, so our example is like 2x plus 3 divided by 4x plus 7. So look here, our integrand look like there's a linear function in numerator and there is another linear function in denominator. So what you have to do, name this function as linear one and name this function as linear 2. So what we have to do, we have to just write 2x plus 3 in term of k1 4x plus 7 plus some k2, and we have to just find the value of k1 and k2. और हमने ये पार्शियल फ्रैक्शन में सीख रखा है, लाइक कैसे कंपेयर करते हैं एलएचएस एंड आरएचएस को एंड ट्राई टू फाइंड द वैल्यू ऑफ constant, like k1 and k2 are constant here which has some specific value. So what we have to do, we have to just compare the LHS and RHS one and try to find the value of k1 and k2. So 2x plus 3 is equal to 4x k1 plus 7 k1 plus k2. So if we compare here, we know that the coefficient of x in LHS is 2, right? The coefficient of x in the LHS side is 2. The coefficient of x in RHS be 2. So what we have to do, we have to just equate it. So what is it? 4k1 is equal to 2. So we get the value of k1 will be 1 by 2. अभी अगर यहाँ पे देखते हैं तो k1 and k2 are the constant. So the 7k1 plus k2 also will be a constant, which is equal to the constant term. So 7k1 plus k2 is equal to 3. So if we calculate the k2 term, it will be like 3 minus 7k1 and 3 minus 7 by 2 because the k1 value is half. So when we equate this, what we get, the term is minus 1 by 2. I hope you'll all understand this, what I'm saying. So now let's move to its integration. So we have to integrate 2x plus 3 by 4x plus 7 dx. And what I just done, I just write linear function which are written in numerator as into the form of denominator function. So how can we treat it as the k1 linear 2 plus k2 by linear 2 dx. So if we put the value of k1 and k2, so our k1 value is 1 by 2. The linear 2 function is 4x plus 7 and minus 1 by 2 divided by 4x plus 7 dx. And when we solve this, it leads to a problem like half dx minus 1 by 2 of 1 by 4x plus 7 dx. So if we integrate this, we reach to the result like x minus 2 minus 1 by 2, and we know the integration of 1 by 4x minus 1 by 4x plus 7 will be 1 by 4 ln. We apply the property 4. अगर यहाँ समझने में दिक्कत हो रही है देन गो टू द लेक्चर 1 जहाँ पे हमने प्रॉपर्टी सारी डिस्कस कर रखी हैं. So it will be form like ax plus b, so 1 by a. Okay, I hope you'll all understand. अगर समझने में दिक्कत हो रही है like 1 by 4 कैसे है, so go to the lecture 1, वहाँ पे प्रॉपर्टी 4 तो वो समझा रखा है मैंने. So it will be easy for you to understand. So mod of 4x plus 7 and plus some constant. So this is our integration. So this is the one of the approach to solve this kind of problem. If our integrand look like linear 1 by linear function by linear function. I hope you'll all understand this, what I'm saying. So let's move to it's one more example, which also based on the type 1. So example 2. So our integrand look like x minus 1 by root under 3x plus 2 dx. And it is of the form like linear 1 by root over linear 2. This is our first linear function, and this is our second linear function, which is of the form like root under L2, right? So we again know that how to approach. We have to write the linear 1 function with the form of linear 2. Just equate and calculate the value of k1 and k2. So our this type of integrand leads to into a simple form. So let's try to find its value. So we have to just write x minus 1 in the form of k1, 3x plus 2 plus k2 and just equate. So what we get, 3k1x plus 2k1 plus k2 is equal to x minus. So when we compare here LHS and RHS, what we get, the coefficient of X in LHS, coefficient of X in LHS is 1, right? Because here 1. So what we have to do, the coefficient is 1. So it must, like in RHS, the coefficient of X must be 1. So it will be like 3k1 is equal to 1. So we get the value of k1 which is equal to 1 by 3. And then let's move to the constant term. So in LHS, the constant term is -1. So in RHS, the constant term must be equal to -1, k2. So if we have to find the value of k2, it will be -1 minus 2 k1. -1 minus 2 by 3, and it is equal to -5 by 3. I hope you'll all understand this, and let's write our linear function. Let's write our integrand, which is x minus 1 by root under 3x plus 2 into a new form, which look like k1 L2, and this will be the minus 5 by 3 root 3x plus 2 dx, right? And when we solve this problem, we lead to like 3x plus 2 dx minus 5 by 3 integration of 1 by root under 3x plus 2 dx, right? And we know that this both integrand of the form like integration of root x and integration of 1 by root x. And we know that the integration of root x क्या होती है 1 by 2 x to the power 3 by 2, right? Sorry, 2 by 3 x to the power 3 by 2. Basically करते क्या है, we have to add just one power and whatever we get divide it by. It like x power 3 by 2 and there will be like 2 by 3. I hope you'll all understand this, what I'm saying. So let me erase it here. Okay, so when we solve this board problem, we lead to the result and apply the property 4. So we lead to the result 1 by 3, 3x plus 2 to the power 3 by 2. Let me erase this first. Okay, so we lead to the result 3 by 2, and there will be the constant function 1 by 3 again, minus 5 by 3. It will be like 2 by 3 and root under 3x plus 2 dx. Dx I'm saying, plus constant. So this is our final integral. I hope you'll understand this. So let's move to the some example of type 2. Some example based on type 2. Okay, so what's our type 2? Try to recall. Our type 2 something look like linear by quadratic function, or linear by root over quadratic equation, or linear into root quadratic. So what we have to write, we have to write just the linear function where L is linear function, obviously, and Q is our quadratic function. So what we have to do, we have to just write this linear function into differentiation of the quadratic function and put some constant here and just equate and find the value of k1 and k2. So let us move to the example, जिससे और अच्छे समझ में आ जाएंगे. So our example 1 is something we have to integrate a function which look like 3x by 4, 3x plus 4 and x square plus 5x minus 9 dx, right? So if we notice here, in numerator, this is our a linear function, and in denominator, there is a quadratic function. So what we have to do, we have to just write the linear function, which is 3x plus 4 into some constant and differentiation of quadratic equation. So the differentiation of quadratic equation is 2x plus 5. We have to just differentiate this quadratic with respect to x. So we get 2x plus 5 and plus some constant another one. And again compare and try to find compare the LHS, compare LHS and RHS to find the value of K1 and K2. And when we do so, so coefficient of X in LHS is 3. So coefficient of X in RHS must be 3. Therefore, 2 K1 is equal to 3. So value of K1 is 3 by 2. And 5 K1 plus K2 is equal to 4. 15 by 2 plus K2 is equal to 4. So when we solve for K2, we get 4 minus 15 by 2, which is equal to minus 7 by 2. I hope you'll all understand this. And then let's write our integrand in new form. So how it look like? Our integrand look like 3 by 2, 2x plus 5 minus 7 by 2 divided by x square plus 5x minus 9dx. Okay. So now what I have to do, I have to just separate the both of the integrand 2x plus 5 x square plus 5x minus 9 minus 7 by 2 1 by x square plus 5x minus 9dx, right? And we know that and we know that uh, if this is a function f, so this is its differentiation, right? So if we use the technique of substitution here, like if we substitute x square plus 5x minus 9 is equal to some function f, so in numerator df is created, right? So 3 by 2, it's something look like it's integration of df by f. If you will not understand, let me write here how I'm saying. Like if we differentiate the function f, let's try to use the technique of substitution here. And we substitute here the value of quadratic equation be a function f. And when we differentiate, what we get? 2x plus 5 dx is equal to df, right? So this function something look like df by f. So when we integrate this function, we will ln f, right? Mod of ln f. And let me write here. And first I'm integrating this function. First I'm integrating this function. Okay. Then we integrate this integrand in a separate way. So first I have to erase this. What I do, you have to understand. I think समझ में आ गया होगा. We just use the method of substitution to solve this. Okay. So 3 by 2 ln mod f. So it look like 3 by 2 ln mod of x square plus 5x minus 9. Now integrate this integration. So this integrand is the form of 1 by quadratic. And we read some standard basic form of algebraic expression. So what we do, either we try to convert this function into a perfect square where y is a perfect square, or some constant plus minus some constant square. So try to reduce this form to, I think here 7 by 2. So try to reduce this 1 by quadratic form to a perfect square and some constant form. So when we do that, how to do? X square, we have to introduce a 2. So it will be like 5 by 2x. And then this is our A term. So this is our B. So we have to create something square, like 25 by 4. So we have to do like minus 9 plus 20. 5 by 4. We just add and subtract 25 by 4. What I do here, I just try add and subtract the 25 by 4 because the square of 5 by 2. So it will look like minus 7 by 2 x plus 5 by 2 whole square minus 61 by 4 dx. So it's of the form like 3 by 2 ln x square plus 5x minus 9 minus 7 by 2. This expression of the form like integration of x square minus a square, right? Where a is equal to root 61 by 2. I'm saying about this, right? And we know the integration of this will like 1 by 2a ln x minus a by x plus a, right? I hope you'll all understand. So try to reduce it to form that. So ln mod of x plus 5 by 2 minus root 61 by 2 and x plus 5 by 2 minus plus root 61 by 2 and mod and plus put some constant here. So this is our, and we miss something which is like 1 by 2a. So 1 by 2 into root under 61 by 2. So it get cancelled. So our new form will be like 3 by 2 ln mod of x square plus 5x minus 9 minus 7 by 2 root 61 ln and x plus 5 by 2 minus root 61 by 2 divided by x plus 5 by 2 plus root 61 by 2. Put mod here and put some constant here. Okay, so this is our final integral. So this is the example based on type 2 कि if अगर कहीं पे भी आपको एक ऐसा फॉर्म दिखता है, एक ऐसा इंटीग्रेंड का फॉर्म दिखता है लाइक लीनियर बाय क्वाड्रेटिक टाइप का, so you have to approach in this way, right? Okay, so let's move on to the type 3 problem, type 3 example. So our type 3 will something look like quadratic function by quadratic function or quadratic by root quadratic function. Something look like quadratic by quadratic function or quadratic by root over quadratic function. It's something look like that. So what I am supposing to do you कि आपने बस करनी है, we have to write the quadratic function which written in numerator as into the form of quadratic equation 2 plus differentiation of quadratic equation which written in denominator, put some constant here. And then equate and find the value of K1, K2 and K3 and then solve the problem. So let me do it here. So take an example. Our example look like example 1. So our integrand look like 3x square plus 5x plus 7 divided by 2x square plus 8x minus 9 dx. Right? So what we have observed here कि our integrand look like quadratic by quadratic form. I'm in this form. So what I have to do, I have to just write the quadratic. This is our quadratic one. The function in the quadratic function in numerator. This is our quadratic one. This is our quadratic two. I hope you will analyze this from this expression as well. Okay. So 3x square plus 5x plus 7. We have to compare it to the RHS of something look like K1 and the quadratic 2 which will look like 2x square plus 8x minus 9 and plus K2 differentiation of quadratic function in denominator. So when we differentiate this, what we get? 4x plus 8. 4x plus 8, right? 4x plus 8. and put some constant here as well. Okay. Now try to find the value of each and every expression. So first go with the coefficient of x square. First go with the coefficient of x square in LHS is 3, right? So it must be like in RHS, the coefficient of x square must be 3. And in RHS, the x square term only come from the first expression. So what we write, 2k1 is equal to 3. So we get the value of k1 is 3 by 2. Now let's move on to the k2 term. Now let's move on to the coefficient of x. So we get the coefficient of x from LHS, it will be equal to the 5. And when we move to the RHS term, so it will be equal to 8k1 plus 4k2. Like one from get one coefficient of x we get from here, another we get from here. So it will be equal to 8k1 plus 4k2, right? So 8k1 plus 4k2. And we know the value of k1, substitute here. And when we solve this, we get the value of k2 is equal to 5 minus 24, 5 minus 12 by 4, which is equal to minus 7 by 4. Okay. And when we solve for the k3, we similarly got 69 by 2. Try to solve it. Try to solve the constant term. So you get the 69 by 2. Now let's move on to the our integrand. So our integrand look like I1 is equal to k1 dx plus k2, the differentiation of quadratic equation 2, 2x square plus 8x minus 9 and plus some constant dx. 2x square plus 8x minus 9. So it is of the form basic algebraic जो हमने पढ़ा है स्टैंडर्ड केस 9 केसेस थी ना लाइक इसको रिड्यूस कर सकते हैं हम लोग दिस ऑफ द फॉर्म 1 by quadratic. So 9 standard form like put some create some perfect square term and some constant term. So plus minus constant square term. So we can solve it easily. So when we do here, this will be equal to like 3 by 2x. And when we integrate this function, so this is our f function, so this is our df function, right? So this directly equal to minus 7 by 4, which is our k2, and ln 2x square plus 8x minus 9. And this is and this function is of क्या बोलते हैं स्टैंडर्ड फॉर्म. तो इसको अलग से एक बार कैलकुलेट कर लेते हैं. So when we integrate this function, the value of k3 is 69 by 2, right? So when we integrate this function, dx by 2x square plus 8x minus 9. So what is our approach? First, make the coefficient of x square as 1. Like 1 by 2, 1 by x square plus 4 plus 16x, right? We just take the 2 common. Okay. So there will be like 4x minus 9 by 2, right? So what we have to do now? We have to create here the square term. So 1 by 2 x plus 2k whole square and minus root under 17 by 2. So it is a form like again x square minus a square term, right? X square minus a square term. So what we have to do here? We have to just substitute here by like 1 by 2a form. So it's something be equal to, here is k3 as well. K3. So it will be like equal to 69 by 4, 1 by 2a. It's integration like L 1 by 2a ln x minus a by x plus a. So 1 by 2 root 17 by 2 as well, and ln x minus a by x plus a and plus some constant. So this is our integration, and cancel this to 2. So our overall integrand look like 3 by 2x minus 7 by 4 ln 2x square plus 8x minus 9 plus 69 by 4 root 17 ln x plus 2 minus root 17 by 2 divided by x plus 2 plus root 17 by 2 plus some constant. So this is our solution or integral of asked integral. I hope you'll all understand this. Uh, so now move to the some next type, some standard type. So our type 5 is if your integrand, if your given algebraic integrand something look uh like what I'm saying 1 by ax square plus b and root under px square plus q. So what is written here? Here written two quadratic function in denominator with missing coefficient of x. ठीक है यहाँ पे एक क्वाड्रेटिक फंक्शन लिखा हुआ है रूट ओवर अनदर क्वाड्रेटिक फंक्शन लिखी हुई है जहाँ पे x वाली टर्म मिसिंग है राइट सो हाउ टू अप्रोच दिस काइंड ऑफ प्रॉब्लम सो व्हाट वी डू वी here take the something common like x square common ले लेते हैं and then we substitute some whatever we get inside the root we substitute it to t square. So let me show you what I'm saying. So I'm just saying ki, take x square common from both, right? So if you take common x square from both of the quadratic equation, so what we get x square a plus b by x square. And then we take x square common from this. So we get outside the x and p plus q by x square, right? So here we get 1 by x cube, a plus b by x square and root under p plus q by x square. So we can write this function as 1 by x cube, a plus b by x square, root under p plus q by x square, right? And then what I have to do, I have to substitute the p plus basically whatever inside the root, we just substitute the term to t square. This is our basic substitution. Okay, so let us understand this fifth type with some basic example. So our example will be, okay, so our first example is of type, it seems like dx by x square plus 1 and root under 2x square plus 5. So this both equation look like this is a quadratic function 1, this is a quadratic function 2 with missing x term. So I just tell you how to approach this. So first take the x square term common. So dx, we take the x square term common. So we get 1 by 1 plus x square. And from here 2, so what we get x2 plus 5 by x square. So we get 1 by x cube dx 1 by 1 plus x square and root under 2 plus 5 by x square. And I just told you whatever written inside the square root, just put it t square. So substitute 2 plus 5 by x square as t square and then differentiate it. So it will be like minus 5 into 2 by x cube is equal to 2t dt. 2t dt like dx minus 10 by x cube dx is equal to 2t dt. right? And then what I have to do when we solve this, we get some, our integrand look like minus 1 by 5, our 1 by x cube minus 1 by 5, how just simplify it. So we get dx by x cube is equal to t dt by minus 1 by 5, right? So let me erase it here first. Okay, so our integrand look like, minus 1 by 5 t dt. And how can we write? Because we substitute here 2 plus 5 by x square as t square, right? So 5 by x square term is t square minus 2, right? And we have to write like 1 by 1 plus x square. So 1 by x square is equal to t square minus 2 by 5. And when we add both sides, we get the favorable term. So we get like t into 1 plus t square minus 2 by 5. And when we solve this, we get to a simple result 1 by 5 dt t square plus 3 dt, right? And this is of the form like a square plus x square integration. And we know that the integration of this part is look like 1 by a tan inverse x by a. So minus 1 by 5. Our a value here is root 3 because we have to write into this form 1 by t square plus root 3 square. So our a value will be like root 3. So 1 by a tan inverse x by a. So our x will be like t and a will be like root 3. So when we substitute here the original value of x, so what we get minus 1 by 5 root 3 tan inverse, we substitute x square 2 by 2 plus 5 by x square. Let me read it. So 2 plus 5 by x square, we substitute 2 plus 5 by x square as t. And here we get 2 plus 5 by x square divided by root 3 plus some constant c. So this is our integration result. I hope you'll all understand this. So let's move on to the next type, which is actually important, quite important, because it's uh, mainly asked in JEE Mains or sometimes in the advanced too. So let's move on to the type 6. So this is our type, something look like x square plus minus 1 divided by a biquadratic x to the power 4 plus kx square plus 1, or x square dx divided by x to the power 4 plus minus kx square plus 1, or dx by x to the power 4 is a biquadratic plus minus kx square plus 1. So this is our type 6, where our integrand look like a quadratic function in numerator and a biquadratic function in denominator, in which in numerator the coefficient of x is 0 and in denominator coefficient of x cube is 0. So let's see how to approach this problem. So we have to do some things like, let me add some page here. So what we have to do first, there's step first, divide numerator and denominator by x square, and then try to form the derivative of x plus 1 by x and x minus 1 by x in numerator. This is the first step. अभी समझ में नहीं आ रही है, so don't worry, एग्जाम्पल देंगे तो उससे चीजें अच्छे से और समझ में आने लगेंगी. And we know that the differentiation of x plus 1 by x is, its differentiation is 1 minus 1 by x square, And the differentiation of x minus 1 by x is 1 plus 1 by x square. Okay, and we know that we can also write 1 as 1 by 2 of 1 plus 1 by x square plus 1 minus 1 by x square. And we can write 1 by x square as 1 by 2, 1 plus 1 by x square minus 1 minus 1 by x square. Okay, so we just use this kind of step to solve this kind of problem. So let's move on to the example. Example such as one में आ जाएंगी. So our example one look like integration of x square plus 1 and then divided by x to the power 4 plus 7x square plus 1 dx, right? So if we observe our integrand look like there's a fraction in which in numerator there's a quadratic equation with missing x term, and there is a biquadratic equation in denominator with missing x cube term. So what is our first step? We just divide by x square in numerator and denominator. So if we divide by x square, we get 1 by 1 plus x square dx, and then x square plus 7 plus 1 by x square, right? So it will be like 1 by 1 plus x square plus 1 by x square. We just rearrange into some good form. And then what can I do? We can write uh, this function as, let me write here. We have to create this denominator function. Either we have to create the x plus 1 by x minus 1 by x square plus some constant, or x plus 1 by x cube whole square and some constant. So here we can create it as like 1 by 1 plus x square dx to like a square plus 2ab, because our ab term is given a square b square if we substitute here. And our b square term will be look like something look like 1 by x to the power 4 kind of thing, and right, so it will be like 1 by x square, and let me erase here, I do simple mistake. Okay, so what I do here, I just create some 2 here, and let me use my pen. Okay, so you can do anything what you want, but we have to notice that the differentiation of x plus 1 by x is 1 minus 1 by x square. If we create the here here the integrand lead to conversion into x plus 1 by x square. But in numerator, our term is given 1 plus 1 by x square. So we have to convert like x minus 1 by x. Differentiation is 1 plus 1 by x square. So we have to create into a negative, like x minus 1 by x square के हमें perfect square बनानी है. To put minus here. So what I just do, we have to substitute here minus, and then plus 7, and we do minus 2, so we have to add plus 2. So it look like 1 by 1 plus x square dx, x minus 1 by 2 whole square, x minus 1 by x whole square, sorry, plus 9. And if we assume this function as f, so this is our df function. So our integration will be simply look like, this function will look like a square plus x square, right? So our integration simply look like 1 by a, where a is equal to 3. We can write it as 3 square, no? So our integration look like a square, a square is equal to 9. So we can write a as 3. So 1 by a tan inverse of x by a. So x minus 1 by x by 3. Put some constant here. So I hope you'll all understand this what I'm doing. So मैंने बस यही करा है कि पहले हमें क्या करनी क्या थी, एक्स स्क्वायर से डिवाइड करना था, एंड देन वी हैव टू क्रिएट then we have to create the derivative in numerator of denominator. तो हमारे पास एक क्वाड्रेटिक इक्वेशन आया. सो अगर इसे हम लाइक हमारे पास 1 + 1/x² एंड वी नो दैट द डिफरेंशिएशन of something which we get 1/1 plus x square is x minus 1 by x. So we have to create the perfect square of x minus 1 by x in denominator. Let us try to take some another example in it, so it will be clear to all of you. So let us move on to the next example, which something look like uh, example 2. So example 2 will be integration of x square minus 1 dx divided by x to the power 4 minus 7x square plus 1. So here again our integrand look like into a fraction in which in numerator there is a quadratic function with missing x term, and there is a biquadratic equation with missing x cube in denominator. So what I have to do? I have to do first step is like divide by x square. So 1 minus 1 by x square dx, and x square minus 7 plus 1 by x square. It will be like integration 1 minus 1 by x square plus 1 by x square minus 7 dx. Now we know that we have to create its differentiation in numerator. So we know that the differentiation of x plus 1 by x is 1 minus 1 by x square, right? So try to create the perfect square of x plus 1 by x. So what I have to do? 1 minus 1 by x square plus 2ab. Just add and subtract by 2. So 1 plus x square minus 9 dx. So our integrand look like minus 1 by x square dx. X plus 1 by x whole square minus 3 square. So this equation of the form, if this is our f, if this function is our f, so in numerator this is our df, and it is of the form like df by f square minus a square something. Its integration is 1 by 2a ln f minus a by f plus a. So when we integrate this, we reach the result like 1 by 2a. So 1 by 2 into 3 ln x plus 1 by x minus 3 by x plus 1 by x plus 3, right? And put some constant here. So our it look like 1 by 6 ln mod of x plus 1 by x minus 3 and x plus 1 by x plus 3. I hope you'll all understand this, what I'm saying. So these are some basic standard type, like how to deal with this kind of thing. So today I introduce a new type, which is something look like, and tomorrow we deal with it. Okay, so tomorrow we will watch some more type, some more algebraic type, and then we move to some standard trigonometric integrand and its spatial types also. So today I introduce a new type. What is type number? I forget. So already type number star. I forget, man. So that's why. Okay, so our type look like there is an algebraic integral which has higher exponent in in denominator. Okay, so like question dx by x minus 1 to the whole cube and x plus 2. We can solve this problem with the help of partial fraction as well. हमने इस तरह की प्रॉब्लम में सॉल्व भी करी होंगी by using our third technique, which is a method of partial fraction. So we can solve this kind of problem with the help of partial fraction, but there is a way like to solve this kind of problem, and the way is जिसके भी पावर डिनोमिनेटर में मैक्स है, पुट इट एज 1/t, like put x minus 1 as 1/t and then try to solve. It will be simple than partial fraction sometime. So you have, so when you practice question a lot, so होगा क्या कि क्योंकि इंटीग्रेशन की क्वेश्चन एक से ज्यादा वैसे भी बन रही होंगी, सो यू हैव, जब आप प्रैक्टिस करोगे तो आपको समझ में आ जाएगा कि कौन सा वे कब लगाना है, बिकॉज दिस प्रॉब्लम कैन बी सॉल्व विद द हेल्प ऑफ partial fraction, right? But it can be solved when we substitute the highest power as 1/t and then try to reduce it to form. So in tomorrow lecture we deal with some more algebraic type which जो कि आईआईटी जैसे एग्जाम में पूछे जाते हैं, जेई मेंस वगैरह में पूछे जाते हैं. सो दैट दैट इज फॉर टुडेज लेक्चर. थैंक यू, थैंक यू, थैंक यू एवरीवन.